Dear teacher, I'm Joshua C. Degas. So the lesson for today is modeling with function. So what is modeling with function? So modeling with function is an introduction to worded problems. We use them to understand the real-life problem situation. It is a method by which we start with an actual situation and arrive at a quantitative solution. These word problems do have an important application or the purpose for our day-to-day life basis, whether you have your own company or business, or you are an engineer or just a vendor. It is somehow a bit complicated for someone, but these problems just need a deeper understanding so that you can be able to solve it. Example problem here. So, the volume of a gas having constant pressure is directly proportional to the absolute temperature. So, the problem A or the required is at temperature of 250 degree with volume of 100 cubic meter. So, first of all, in every problem, you need to identify the quantities or the variable. So, the variable of volume is represented V. The P represented the pressure. The variable P represented the absolute temperature. So, first of all, this is our formula to find the volume. So, V is equals to K times T. So, the K is a constant of proportionality. So, how to find volume? We need to find the constant of proportionality first. So, the given is 200, temperature is 250 degrees, and the volume is 100 cubic meter. So, let's plug in the value. So, first is 100 is equals to K times 250 degree. So we need to derive this equation in order to get the constant of proportionality. So how to do that? Simply divide 250 to cancel out, then the remaining variable would be k. So we can get here k is equals to 100 divided 250 is equals to 4 over 10, and simplify further is equals to 2 over 5. So we have the first equation, which is this. V is equals to F times T is equals to 2. So we have our K now. So next, the problem B, the given is 245 degrees and the volume is missing. So how to get the volume? So problem A, we get the constant. We have the constant actually. So we just only need to use this formula again to have to get the value of volume. So V is equals to K. So we have the value of K now, which is 2 over 5. Then just multiply to the given value, which is 245. So we come up with the answer of.
So let's talk about a example of a modeling function. So first, a rec- let's read the problem. So a rectangular lot is bounded at the front by a river. No fence is needed along the river, and there is to be a 48 feet opening in the back. If the fence along the back costs 3 pesos per foot, along the side of 2 pesos per foot, find the dimensions of the largest lot, which can be thus fenced in for 600 pesos. Sorry. So uh, when you conceptualize this problem, uh, this would be the output. So rectangular lot where in front of it there's a river, where in front of the rectangular lot, there is no fence being placed here. So in order for us to know what is the area of this certain problem, we must use the area of rectangle. So in order for us to know what is the area of the rectangle, we must use the length times width. So before we proceed that, we will go for a modeling first. So this would be the solution. So 600 means that the total, this is the total area of the rectangle. 2y means that 2 pesos per foot, and plus 3 means that 3 is multiplied by x minus 48. Then the this would be for the x. Then in order for it to be simplified, the 3 must be transposed here. So 3 times x and 3 minus 48 times negative 48 would be 3x minus 144. So 144 will be transposed here. So it will negative, it will become a positive. So 600 plus 144 is equals to 744. So in finding the y rectangular lot of y, we must divide by 2 because we must only use only the variable. So cancel, then divide all by 2. So it will be left, the 3x will be also be transposed here. So this would be the formula for y. So this is the formula needed to find y. So in order for us to find y, we will input this formula in our area of the rectangle. So this would be the area of the rectangle. So area is equals to x times y. So area is equals to x times 372 minus 1.5x, which is here is already given. So when you transpose, distribute it, sorry, the given would be this one, 372x minus 1.5x squared. So to find it, we must derive the area for in order for us to find the x. So it will the 372 derive it will become a 372. Then 1.5 times x squared will use a power rule. The 2 will bring down, then 2 minus 1, it will become x, so it will become a 3x. So the 3x will be transposed here, so because we must find only the variable of x. So 3x is equals to 372. So uh, like we said earlier, we must only find the variable only. So we must cancel this one to be so the x will only be left out. So 372 divided by 3 is equals to 124 feet. So therefore, the x of the rectangular lot, which is here, is 124 feet. So in our so x has uh, already been find out. So next is in order for us to find y, which is here, here, we must input. We already find the x. So let's go back to the last. Wait, sorry. Here y, because this is the formula to find the y. So y is equals to 372 minus 1.5 multiplied by 124, which is the x. X is here, which is 124 feet. So when you simplify it, uh, the outcome will be 186 feet. So therefore, um, in this concept of the problem, therefore in here, there would be, in this one, it would be 186 feet. And here, x would be 124, yes, 124 feet. So that's it. We solved the problem.
So this is a mathematical model. A rectangular box with a square base now top has a volume of 2000 inches squared. If the surface area is 900 inches squared, what are the dimensions of the box? So this is the steps. Write an equation of the volume of the box. Step 2. Rearrange the volume of the box using the drawing. Step 3. Write an equation of the surface area in the box. Use the fact that there are 4 sides into the button. Step 4. Substitute your result for h into the surface area equation. So the given is 2000 inches squared, and also the area is 900 inches squared. So this is the example drawing, and in my understanding, this is the formula. Volume equals s squared h. So the volume is 2000 equals s squared h, and the 2000 is divided by s squared equals h. So SA equals 4sh plus s cube is equals to the area of 900 4sh plus as2. So this is the equation. 900 equals 4s open parenthesis all over 2000 all over s squared equals plus s squared. So this is the answer. 0 is all over s plus s cube minus 900. So we compute the dimension of the given area. So 2000 all over 10 squared. This is the dimension of the cube. 2000 all over 10 squared. We will multiply. The answer is 20. So the dimension is 10 by 10 by 20. So this is the final answer. So thank you.
So this is my problem. So the problem is a tube is needed for a water company for hydraulic purposes. They have the specific tube that they want, but they want to know how much volume of water can it hold. So the radius of the cylinder of the tube is 5 meters. And the height of the cylinder is 10 times its radius, so you gotta find, so the question is find a function that can find the height. So first things first, the formula of the volume of the cylinder. So this is the formula of the cylinder. So we're gonna start over here, this, and then on the problem, what you can see in the beginning of this video is that it is stated there that the height is 10 times is 10 times the value of the radius. So we're gonna put it here. Then substitute after that. And this is what it looks like after this. Then after this, what you're gonna do is just multiply each other. Then the answer, then the result is this. So that's it. That is the function for, so that you can find the height.
Selmi Antoniano. I am now going to discuss or solve an easy word problem using a function. So we have an example here. A bakery company produces boxes to package their cakes and cupcakes. The box must have the following proportions. The height should be 3 times its depth and the width should be 2 times its depth. So we need to find this following. First, we have to find the function. We have to find the function that models the volume of the box in terms of its depth, and find the volume of the box if it has a depth of, let's say, 2 inches. So the first step, or the first thing we're gonna do about this problem is that we need to identify the quantities in here. So for this problem, we have the height, the depth, and the width as our quantities. Since we are asked to find the volume of a box, let's have a quick review on the formula of the volume of a box. Volume is equal to depth times the width times the length. This is now the formula we are going to use in our problem. Let's just rewrite it here. Volume is equal to depth times the height times the width. So this is now the formula. So in order for us to easily identify these quantities, let's replace them with the variables. For the volume, we have here a capital letter V, which represents the volume. And for this, let X be the depth of the box times the height. So referring to our question here, or to our problem, height is or should be 3 times its depth. So we'll rewrite it as 3x. Times, as for the width, it should be 2 times its depth. So we'll rewrite it as 2x. So we have to solve this. 1 times 3 times 2 is equal to 6x to the power of 3. This is now our equation for the volume. So in order to answer letter A here, let's say, so the model is the function V that gives the volume of the box in terms of the depth of the X. And as for our last part, so we use this model to answer the questions in part B, which is to find the volume of the box if it has a depth of 2 inches. So if the depth of the box is 2 inches, let X be equal to 2. Then we'll just simply plug in the 2 here in our x's. V of 2 is equal to 6 times 2 cube. So the answer would be 48 inches. That's all for today.